Hi, I'm Patrick. Thanks for being here. It's an honor to me to be here and to do a presentation about here. And thanks for already introducing the topic. So it's a, let's call it cloud migration adventure, including all the obstacles, or at least most of them, and yeah, some problem-solving approaches. And I also would like to explain how did we use Terraform. So again, hi, my name is Patrick Koch. I'm a DevOps engineer at AVL. I will explain the company later on. I try to make meaningful contributions to the community by giving workshops, organizing meetups, and of course, I like to be on conferences. And as you probably may notice, I'm from Austria. It's the country between Italy and Germany. And we use some kind of German, almost Bavarian. So I think it fits good to be here. Okay, what can you expect from my session? I would like to start with a short introduction about my company and about the legacy software application, who is somehow the main actor during the cloud migration journey. At chapter 2, I would like to describe you the initial situation. So what did we do before we tried to do some stuff in the cloud? Chapter 3 is about the cloud migration journey in detail, including the mentioned obstacles. At point 4, so we proved that it works in general, but what are the next steps? And finally, at point number 5, I would like to explain how did we use Terraform and which benefits we could derive during the cloud migration adventure. And the session ends with a conclusion. Okay, let's jump into the topic. You probably never heard about AVL. So our business is the automotive industry. We are located here in Graz. Who has heard before that of Graz? Oh, quite a lot, okay. And who heard about the Terminator? So this guy was born in a little village in the northwest of Graz, so it's probably our most popular living person. And this description always helps. And as you're aware that the automotive industry is in some kind of a transition, and so we are. And we are also trying to focus on new areas, including e-fuel, electrification, of course, autonomous driving assistance systems, etc. And our probably most well-known product is an engine testbed. You will see it later on what this is. And finally, to conclude the introduction part, may I introduce you AVL Concerto. It was established almost 3 decades ago. It's a Windows application, a desktop application, and of course, although it's a legacy application, there is of course a development. So we did a lot of things. So at 2014 we introduced managed codes. Yeah. So and we put a REST interface into it, added Python support, and finally we got the message, it should run also in the cloud. And to be honest, we didn't expect that. But so the key message here is quite old software application. The thing is, we developed it, there's a huge technology stack in it, important functions on which the customer rely on, so it's difficult to adapt there. And also, we got the message it should run in a cloud. So, okay, why not? But what did we do before considering any cloud actions? And to get a better context, so that would be, for instance, an engine testbed. So you put a combustion engine on it and you run several tests to get data with regards to the emission, to the speed, etc. I think you know what I mean. And in the end, you get a bunch of data. And after you're having the data, it's Concerto's responsibility, and that's Concerto, to do some kind of post-processing of this data. So as you can see, you can load files, you can put the data in it, and by running specific functions, by running specific functions, Concerto creates some kind of, let's call it, report, which includes diagrams, tables, etc. That would be, for instance, the final result for all the huge car companies. And it looks like that. And you probably now wonder, yeah, it's working. Why should we do any actions in the cloud anyway? And this brings us, and this starts our cloud migration journey. But why did it happen? So again, our traditional use case, engine testbed, combustion engine, we put it on it. It's our unit under test. A guy comes into the company and runs the tests. Let's name it Hermann, for instance. So Hermann runs a lot of tests against the engine testbed, and after 8 hours, for instance, the day it's done, and you get the results. But times are changing, and now we have following situation here on the right side. So those guys here, what you see here, are called battery testing chambers. So one of those battery testing chambers contains several batteries. Each battery contains several modules, and each module contains, I don't know, a lot of test cells. And if we now compare the amount of data which we get from one combustion engine, so after a test run, it's almost the same which we get from one single test cell. So this means that, yeah, a person who runs tests against the combustion engine, yeah, wouldn't be happy to do it 1,000 times, or yeah, I don't know how many times against one single test cell. And this means this forces us, and this was the key, the main driver, to introduce automation and to scale Concerto. So we need immediately several, probably 1,000 instances of Concerto. According to scaling, Kubernetes would work there, of course. But why should we go into the cloud? So in general, we got some requests from customer whether it will run in the cloud, because they would like to migrate to the cloud. And yeah, therefore it was quite simple for us. Let's try to provision all the stuff which we need to scale Concerto, whatever the solution will be. Let's try to use the cloud for that. And there, somehow the pain, but also the adventure started. And the very first thing from a few colleagues from me was, when we heard the news that we should migrate to the cloud, okay, that's now the chance. Let's try to rebuild the whole stuff. It's 30 years old. Well, let's throw it away and let's try to start from new on. But the problem was, at that time, we didn't know which components we should rewrite, because we have several million lines of code and 30 years. And therefore, the first thing was, we have to agree on a cloud migration strategy. So shall we refactor, rebuild it, or shall we try lift and shift? And we had great discussions, and we chose lift and shift because the first thing was, we didn't know where to start, to be honest. Will it ever end at a legacy software application? And we wanted to see the big picture. So what will it look like? And does it work anyway? And the next great thing was, to our luck, at that time we already had a containerized version of it, but it's a Windows container, as we're having a Windows desktop application. And therefore we already had some kind of starting point. So we've decided to make a lift and shift, put the application as it is in a Windows container, and let's hope for the best. And yeah, we we thought, we don't want to invent anything. We want to go according to best practice. And on Microsoft, we got a great solution idea. But the goal should be to implement something like that. So to any kind of resource which is capable to scale Concerto, so those are the orange icons here, to generate the report. And the data we get out from a database, which could be in the managed cloud service or outside because of some sensitive data. So not all of our customers are happy when specific data are really inside the cloud. And we focused on that architecture. So triggering the calculations from the message broker, trying to scale Concerto, and generating the very same reports which we did in a manual way. And the solution idea, according to Microsoft, looked like that. So we have the existing application, so that would be Concerto. We put the corresponding container image to the Azure Container Registry, and by using the dedicated CLI commands, we apply the workload, for instance, on the Kubernetes service, which runs Concerto, which generates the reports, and we get the input here from the, for instance, from the SQL database, and that fits. And so we thought, okay, doesn't look that bad. So log into the Azure portal and try to get it done. So we provisioned an Azure Container Registry, the Kubernetes service, and virtual machine. We use that for a license server, so Concerto just starts up when you can grab a corresponding license feature from a license server. Let's provision an Azure file share to put the reports on it, and the container should run and triggers the calculation inside of it. So it's one thing to provision the dedicated resources, but of course they should work together. And at which points do you think we had some obstacles and we went into troubles? Okay, I solved it. So it's almost everywhere. So we had problems between the AKS and the container registry. We didn't know that we had to attach it properly. We're quite new to it. We couldn't derive a container anyway on the Kubernetes cluster when that was working, because it's a Windows container workload. And so we thought, okay, let's simply add a Windows node to the AKS, then it should work. But it didn't, because if you really don't tell the workload that it has to be scheduled on a Windows node, then it doesn't do that, although the Windows node would be there. And we didn't get it scheduled and was wondering why nothing happened. So what's wrong with you, AKS? According to point number 3, so we set up a license server for the very first time, and there we run into a specific classical IT sysadmin problem. So we simply forgot about to set up the proper firewall rules. So we, as a developer, we provisioned the virtual machine. An IT colleague could tell us, hey guys, you need the firewall rules, please set it up properly. We didn't think about it, to be honest. And so we even didn't come to point number 4 because we struggled at the points before, so don't know whether there would be a problem in addition. But the problem here was, from my point of view, my humble opinion, with almost doing nothing before, according to in the Azure portal, we tried a quite complex solution, including an AKS. So a better approach would have been to simply think of what would be the easiest way to start with to simply get the container running in the cloud. And we couldn't figure it out, so we stopped that approach and we searched for a different approach, and we recognized serverless services. And there exists the Azure Container Instance. And the great thing is, if you already have the container registry with your image on it, and you try to deploy an Azure Container Instance, you simply can choose the image which you would like to have from the container registry. So you don't have to take care about point number 1. And you also don't have to take care about number 2 to get it scheduled on the right infrastructure, so on a Windows node, because the container instance simply managed that for you. And therefore, we could see that Concerto tried to start up. So we still had the problem at point number 3, including the firewall rules. But we could see that Concerto was starting up, and we had the first time hope. And we could figure out that it was about the firewall rules, and Concerto was running for the very first time in a container in the cloud. And so we proved that now the other things should be really about the infrastructure. Because at the time before, we thought it's something wrong with the container anyway. So we could solve that issue. And so just 2 problems left. And after a while, we also figured out that. And here on this short movie, I would like to show you how does the use case, the automated use case in the cloud on the AKS looks like. So here we have, for instance, the share. It's now empty. That's the container registry. And here we move back to the Kubernetes cluster. And now we are going to apply 2 different workloads almost at the same time by kube control apply and using the corresponding YAML file. And then we can see that 2 different workloads are running. And inside the workloads, we run, of course, now the pods. Inside the pods, the container, which triggers a calculation for Concerto. So 2 different calculations are now triggered. Here at the share, you can see that also 2 different directories are created. And inside those directories, we will get the very same report as we would create when we do it in a manual way. So this worked fine. And after a while, we will also open the PDF. Okay, let's also download the second one. So close it, and let's also check that the workloads are completed. So when Concerto stops the calculation, also the workload is completed, and as you can see, get the very same report. And this proved to us that it works in general, and we were of course glad about that. But we were quite sure that the solution on a Windows container is maybe not ideal. So this brings us now to the next steps. So what we're going to do in future. And we've seen that before. So the 2 options, refactoring, rebuild versus lift and shift. So now we had lift and shift. And now we could figure out which components we really need for Concerto to make it performant to being run in a container on the cloud. And we were quite sure we should get it ready for Linux. So therefore, the next thing is now to do a refactoring and rebuild. So we pick the stuff which we need for the automated use case on the AKS, and we are going to create some kind of new product. But before that, we have to throw away a few things. So that would be the structure of Concerto on Windows. So we have a managed user interface, a native user interface, a native data management subsystem, Python.com REST, and that's now it on Linux. So we throw away a lot of stuff. So we don't need that many components for the new use case. And this will end up into a new, it will end up in a new product. And now the amazing thing is, instead of having one single desktop application, we will now have this Linux container here, at which the refactored components of Concerto will run. And in addition, inside Azure, we have the AKS, we have Prefect for the workflow, we have Kata for the autoscaler, we have ClickHouse, we will have MySQL database, Postgres, Elasticsearch, and of course, we provision the resources which we can with Terraform. So that's some kind of amazing transition which we allowed to experience, and it's still a great adventure, and that's the plan for the new product. And we are looking forward to it. And this brings me now to some benefits which we could figure out by using an infrastructure as code approach, so by using Terraform. So the thing which I experienced personally was that it was great to provision the resources which you need on your own. Because before that, I had to create a ticket for the IT. Please create me, for instance, a Kubernetes cluster, and then you wait for it, but some settings probably don't fit. Then you have to recreate a ticket, and nobody wants to create tickets. I don't like it, and it should be banned. And therefore, it was great to have more power. So simply don't wait for a IT guy to do that. You could do it on your own. So empowering the developer. I think I also don't have to tell you the next benefit, but especially in our use case or our proof of concept, it was great to simply versionize the different things which we need, because we did a lot of adaptations to the Kubernetes cluster, for instance, to scale up the nodes, to speed up the calculations, to try to get as much parallel calculations as possible. And therefore, it was also great to simply versionize the Terraform configurations. And next thing, automation. So we are using Azure DevOps for CI/CD, and there's also a great support for Terraform. For instance, if you use the classical editor, but also if you would like to create the pipeline within YAML. And the cool thing is a pipeline can be triggered by anyone. So there's no excuse for anyone if something needs to be destroyed. Also, some colleagues still don't feel that comfortable, of course, if they need to touch the cloud resources. And we tried to get most of the stuff done in Azure DevOps release pipelines or build pipelines. To simply increase our automation. Okay. Also, of course, I think I don't have to tell you that to decrease the costs. So we had a time when we did all the stuff in a manual way. So we were that glad that we made it to create a Kubernetes cluster, which was really working. And of course, nobody wanted to touch it. Nobody wanted to destroy it, but we need to do the adaptations. And unfortunately, the costs increased. And some line manager maybe was yelling at us that we had too high costs. And Terraform, of course, helped there too. And there exist also great free tools to get already some kind of estimation within the Terraform configurations to also estimate it in a better way. That was great too. And the next thing is we continuously get requests from our customer that they would like to have our products getting migrated in different cloud platforms. And now we always tell them, okay, let's do that for you, but we would like to do that with Terraform, and we also ship the configuration files to you, because currently most of the customers have their own subscription. And we simply try to get it done in Terraform, we provision it, and then we send it to them to simply trying to rebuild the whole environment which they need. And this, of course, helps a lot. And this finally brings me to an outlook, respectively to a roadmap. So it's all started in 2019, where we did the very first containerization of Concerto on a Windows container. we invested a lot of effort in 2020 with regard to a CI/CD, so building the container image, deploying it in an automated way on a Kubernetes cluster on premise. Finally, in 2021, we started with the cloud migration journey. So we started with the proof of concept and simply proved that it works in general. In 2022, we had the focus on getting Concerto ready for Linux and try to focus on the parts which we really need for the automation and for the cloud version. And now, finally, this year, we will release a new product, which will be a real cloud native solution. And we are looking forward to that. And we are curious, of course. And now we are at the end of my presentation. I will close it with a conclusion. So we really had a lot of discussions with finding a proper cloud migration strategy to find a proper one. Probably one of our hugest obstacles was that we tried to find not the easiest way to start with. So we could have started more lightweight than we would have been faster, probably. So maybe not starting with a Kubernetes cluster when you don't know anything about it. Maybe let's try it with a serverless service. Of course, using an infrastructure as code approach. Therefore, Terraform helped us a lot, and I couldn't think of any other option anymore, to be honest. And of course, trying to increase the automation by doing the integration in pipelines as much as possible. And maybe some things are quite familiar to you. Maybe you're probably more expert than I am, but I hope this was some kind of meaningful talk for you. And I'm looking forward, of course, to talks with you. And thanks a lot for being here, and hope you enjoyed it. So thank you. Thank you so much. Danke.